Here's a question that might just shake your understanding of science and the self. Why did physics leave the brain behind? To answer that, we need to rewind, not just decades, but centuries, into the golden age of scientific integration. Back when the greatest minds weren't confined to one discipline, but danced fluidly between them. Take Hermann von Helmholtz, a physicist, a physician, a neuroscientist. He measured the speed of neural impulses with one hand and formulated the law of energy conservation with the other. Or James Clerk Maxwell, whose equations underpin all of modern electromagnetism. He also theorized color perception, long before retinal photoreceptors were ever seen under a microscope. And then there's Ernst Mach, known for Mach numbers in aerodynamics, yes, but also for studying how we see contrast in light, a phenomenon now known as Mach bands. These polymaths didn't separate mind from matter. They studied both. Their curiosity wasn't confined by departments or degrees. But then something changed. As the 20th century approached, physics exploded with elegant theories, relativity, quantum mechanics, thermodynamics. Mathematics, particularly linear and local mathematics, was its secret weapon. But this very power exposed a gap, because when scientists turned to the brain, those same tools broke down. Unlike the idealized systems of Newton or Maxwell, the brain wasn't linear. It wasn't local. It didn't hold still long enough to be solved like a tidy equation. It was, and is, a shifting web of interactions, distributed, dynamic, inherently unpredictable. And for a long time, that meant ignored. Even Einstein, in a letter to Queen Elizabeth of Belgium in 1933, wrote, "Most of us prefer to look outside rather than inside ourselves. For in the latter case, we see but a dark hole, which means nothing at all." That dark hole wasn't a lack of curiosity. It was the lack of the right tools. That's where today's episode takes its cue. From Chapter 2 of Conscious Mind, Resonant Brain by Stephen Grossberg, a cognitive scientist and neural theorist who has spent decades redefining how we understand the brain-mind connection. This chapter, titled How a Brain Makes a Mind, traces the moment when science lost touch with consciousness and how we might rebuild that bridge. Grossberg offers more than critique. He presents a full framework for how the brain learns, adapts, and becomes conscious. It's called adaptive resonance theory, or ART. It proposes that our minds don't just passively take in the world. They match, expect, and resonate with it. Picture this. You hear the sentence, "The eel is on the..." Now, if the next word is table, you might hear meal. If the next word is wagon, you're more likely to hear wheel. Even though the original sound was noise, your brain filled in the gap. Not randomly, but based on pattern recognition. This is resonance. The brain activating learned expectations and comparing them with real-time input. When they match, a feedback loop locks in. You become conscious of a sound, a word, a meaning. This matching process requires bottom-up signals from the senses and top-down expectations from memory. Together, they allow us to recognize patterns, adapt to new information, and, crucially, avoid forgetting what matters. Grossberg also explores why this matters beyond theory. The brain's ability to adapt in real time, without being overwhelmed by noise or frozen by old habits, is what allows us to function, to survive, to learn without collapsing. Brains don't rely on fixed code. They use networks that adjust through experience. These networks are nonlinear. They respond differently depending on the context. They're non-local. Processing happens across wide areas, not isolated spots. And they're non-stationary, constantly changing with time and learning. Traditional mathematics couldn't capture this. That's why psychology stalled. But Grossberg builds the missing tools, differential equations that explain how signals flow, how memories form, how expectations shape perception. He shows that brains look the way they do because they evolved to adapt, to handle complexity autonomously, in real time, with no external programmer. And the most profound insight of all, many of these ideas were first discovered by Grossberg before he ever studied neuroanatomy. Just by analyzing behavioral data, how we learn lists, make errors, or adapt to surprises. He reconstructed models that later aligned with real biological mechanisms. That's the genius of it. A theory grounded in mind that leads us directly to brain. So yes, physics left the brain behind. But thanks to thinkers like Grossberg and the brave ideas in Chapter 2 of Conscious Mind, Resonant Brain, we're finding our way back. One resonance at a time. If this exploration opened up something new for you, stay curious. In the next episode of Deep Vices, we'll continue diving into the chapters of this remarkable book, drawing connections between science, perception, and consciousness. We'll explore how vision, hearing, and learning are more than functions. They're symphonies of prediction and meaning. Until then, reflect on this. Your mind isn't just in your brain. It is your brain resonating. This is Deep Vices, where vision meets depth.